Right now, at this very moment, on the southern coast of Denmark, something almost incomprehensible is taking shape. Engineers are building skyscrapers, not upward toward the clouds, but sideways in enormous casting halls the size of aircraft hangars. These are not buildings meant for people to live in. They are hollow concrete giants, each one weighing 73,000 tons, each one longer than a football pitch, and each one destined for the same fate, to be dragged into the sea, floated across the Baltic, and sunk deliberately to the ocean floor. When the last one is lowered into place, they will form the longest immersed tunnel ever constructed by human hands, an 18-kilometer underwater highway and railway connecting Denmark to Germany, stitching together the body of Europe in a way that has never been done before. This is the Fehmarn Belt Fixed Link, and it is, without exaggeration, one of the most audacious engineering projects the world has ever attempted. To understand why this tunnel matters, you need to understand the geography it is designed to conquer. Between the Danish island of Lolland and the German island of Fehmarn lies a strait of open water called the Fehmarn Belt. It is only 18 kilometers wide, but those 18 kilometers have been a barrier for centuries. Today, the only way across is a ferry, a slow, weather-dependent vessel that takes 45 minutes on a good day and doesn't run at all when Baltic storms roll in. For truckers hauling freight between Scandinavia and mainland Europe, it is a bottleneck. For commuters, it is a frustration. For the economies on either side, it is a wall made of water. The Fehmarn Belt Fixed Link is designed to demolish that wall permanently. When it opens, the crossing will take 7 minutes by car and 7 minutes by train. Not 45 minutes, not dependent on weather, 7 minutes around the clock every single day of the year. But here is the part that staggers the imagination. They are not drilling through rock. They are not suspending a bridge from cables. They are manufacturing the tunnel in a factory, piece by enormous piece, and then assembling it on the seabed like some colossal underwater jigsaw puzzle. The method is called immersed tube construction, and while it has been used before in places like the Øresund crossing and the Hong Kong harbor tunnels, it has never been attempted at anything close to this scale. The Fehmarn Belt Tunnel will consist of 89 individual concrete elements. Each element is approximately 217 meters long, 42 meters wide, and 9 meters tall. To put that in perspective, each tunnel section is wider than a 4-lane highway and taller than a 3-story building, and each one weighs as much as a small aircraft carrier. The production of these elements is a story of industrial ambition in its purest form. On the Danish coast near the town of Rødbyhavn, engineers have constructed a purpose-built factory unlike anything the world has seen. They call it the production facility, but that name does not begin to capture its enormity. It is, in effect, a tunnel-making machine, a vast complex of casting halls, curing chambers, and outfitting docks, all arranged in a precise sequence so that tunnel elements move through the facility like products on an assembly line, except the products weigh 73,000 tons each. The process begins with steel reinforcement cages, intricate lattices of rebar assembled by robotic welding systems and human craftsmen working side by side. These cages form the skeleton of each tunnel section, providing the tensile strength the concrete alone cannot deliver. Once the cage is complete, it is moved into the casting hall, a climate-controlled cathedral of industry, where a specially formulated concrete mix is poured in continuous operations that can last days without stopping. The concrete is not ordinary. It is a high-performance, marine-grade blend designed to resist the relentless chemical attack of salt water for at least 120 years. Every batch is tested. Every pour is monitored by sensors embedded within the structure itself, measuring temperature, pressure, and curing rates in real time. The engineers are not just building a tunnel, they are building a tunnel that must outlast everyone alive today.
Once an element has been cast and cured, it enters the outfitting phase. This is where the raw concrete shell is transformed into a functional piece of infrastructure. Mechanical and electrical systems are installed, ventilation ducts, fire suppression lines, drainage pumps, lighting arrays, traffic management sensors, and the rail systems that will carry high-speed trains at speeds up to 200 kilometers per hour. All of this is fitted inside the element while it sits safely on land, in dry conditions where quality control is absolute. This is one of the great advantages of the immersed tube method. Unlike a bored tunnel deep underground, where workers operate in cramped, dark, high-pressure conditions, the Fehmarnbelt elements are built in the open air under factory conditions with full access for inspection and testing. The sea is the last place these elements will go, not the first. And then comes the moment that defines this entire project. The finished element, all 73,000 tons of it, must be moved from the factory to the water. To accomplish this, engineers have excavated an enormous harbor basin adjacent to the production facility. The element is floated out of the casting dock using a controlled flooding process. Massive ballast tanks built into the element structure are carefully filled with water, lowering it to a precise draft depth. Then, a fleet of tugboats, some of the most powerful in Northern Europe, takes hold. Slowly, with a patience that belies the forces involved, they tow the element out into the Fehmarnbelt Strait. The journey across the water is a ballet of controlled chaos. The element, now floating like an impossibly heavy barge, is guided by GPS positioning systems accurate to within 2 centimeters. Weather windows are calculated weeks in advance. The sea state must be calm, the current must be predictable, the wind speed must be within tolerance. If any single variable falls outside the acceptable range, the operation is postponed. There is no room for improvisation when you are maneuvering something the size of a city block through one of Northern Europe's busiest shipping lanes.
Once the element reaches its designated position, the sinking begins. This is perhaps the most nerve-wracking phase of the entire operation. The ballast tanks are flooded further, and the element descends through the water column at a rate measured in centimeters per minute. Divers and remotely operated vehicles monitor every angle of the descent, feeding live data back to the control room on the surface. On the seabed, a trench has been pre-dredged to exact specifications, its bottom leveled with a gravel bed that has been screened, washed, and placed with millimeter precision. The element must land on this bed and align perfectly with the element already in place beside it. The tolerances are extraordinary. We are talking about connecting 2 73,000-ton concrete boxes on the floor of the Baltic Sea with a watertight seal that must hold against water pressure, ground movement, and the passage of more than a century. The connection is made using a system of rubber gaskets and hydraulic jacks. Once the new element is in position, water is pumped out of the joint space between it and the previous element. The pressure of the surrounding sea pushes the new element forward, compressing the gaskets and creating an immersion joint that is completely watertight. Engineers then enter the joint space from inside the already completed section of tunnel to inspect the seal, bolt the elements together with massive steel brackets, and verify that the alignment is perfect. Only when every check is passed does the next element begin its journey from the factory. The scale of the trench alone is a marvel of marine engineering. Before a single tunnel element can be placed, the seabed must be prepared. Dredging vessels, some equipped with trailing suction hopper technology and others with massive cutter heads, have carved a channel across the floor of the Fehmarnbelt. The trench is approximately 60 meters wide and up to 16 meters deep in places. The volume of material removed is staggering. Millions of cubic meters of clay, sand, and glacial till that accumulated over the last ice age. This material is not simply dumped. Environmental regulations, among the most stringent ever applied to a construction project, dictate exactly where and how the dredged material is handled. Some of it is used to construct new land areas near the Danish coast. Some of it is placed in designated underwater disposal sites where marine biologists have confirmed minimal ecological impact.
The environmental monitoring program for this project spans hundreds of square kilometers and tracks everything from herring migration patterns to the turbidity of the water column. And this brings us to the cost. The Fehmarnbelt fixed link carries a price tag of approximately 7 billion euros, making it one of the most expensive infrastructure investments in European history. But that number, enormous as it sounds, must be measured against what the tunnel will deliver. Economic studies estimate that the fixed link will generate more than 600 billion euros in economic activity across the European continent over its operational lifetime. It will slash travel times between Scandinavia and Central Europe. It will shift millions of tons of freight from congested road networks onto fast, efficient rail lines. It will create a seamless transportation corridor from Copenhagen to Hamburg, two of Northern Europe's most dynamic cities, separated today by an inconvenient stretch of water and a slow ferry. When the tunnel opens, those cities will be connected by a direct rail journey of roughly 2.5 hours. That is transformative. That is the kind of infrastructure that reshapes economies, redraws commuter maps, and redefines what it means to be a neighbor. The workforce behind this project is itself a small city. At peak construction, more than 4,000 workers are employed at the Rodbyhaven production facility alone, with thousands more involved in marine operations, dredging, and onshore construction on both the Danish and German sides. Workers have come from across Europe, specialists in marine concrete, tunnel ventilation, immersed tube technology, and underwater welding. The project has spawned its own training academies, its own safety protocols, and its own innovations. Techniques developed for the Fehmarnbelt Tunnel are already being studied by engineers in China, South Korea, and Norway, who see in this project a blueprint for the next generation of underwater crossings. The engineering challenges extend far beyond the tunnel elements themselves. On both shores, massive portal structures are being built, where the tunnel emerges from the seabed and transitions to the road and rail networks. These portals must manage the immense forces of the tunnel pressing against the shoreline, the weight of the earth above, and the dynamic loads of high-speed trains entering and exiting at velocity. The ventilation system for the tunnel is a masterpiece of fluid dynamics, designed to handle the piston effect created by trains traveling at 200 kilometers per hour through a confined tube. Jet fans installed at intervals along the tunnel's length manage airflow with surgical precision, ensuring that air quality remains safe even in peak traffic conditions. In the event of a fire, the same system reverses airflow direction, channeling smoke away from evacuating passengers and toward extraction points, while fresh air is pumped in from the opposite end. Safety, in fact, has driven every design decision. The tunnel contains two separate road tubes and a single rail tube, with emergency escape corridors connecting all three. Every 300 meters, cross passages allow passengers to move from one tube to another in the event of an emergency. Fire-resistant concrete, tested to withstand temperatures exceeding 1,200 degrees Celsius, lines the interior walls. Automated incident detection systems using thermal cameras and air quality sensors can identify a fire within seconds and activate suppression protocols before human operators have even registered the alarm. The Fehmarnbelt Tunnel is not just designed to be the longest immersed tunnel in the world, it is designed to be the safest.
There is something profoundly human about this project that transcends the engineering. For centuries, the people of Denmark and Germany have looked across the Fehmarnbelt and seen a divide. Fishermen on both sides worked the same waters, faced the same storms, and caught the same herring, yet they lived in different worlds, separated by a moat of gray Baltic water. Trade was possible, but slow. Connection was desired, but deferred. Plans for a fixed link were discussed as early as the 1930s, shelved during the war, revived in the 1960s, debated through the 70s and 80s, and delayed again and again by political disagreements, environmental concerns, and sheer logistical dread. The treaty to build the tunnel was finally signed in 2008. Construction began in earnest in 2020, And now, as the first elements settle into their positions on the seabed, the dream that took nearly a century to crystallize is becoming concrete in every sense of the word. When the Fehmarn Belt Fixed Link opens, likely around 2029, it will be more than a tunnel. It will be a statement, a declaration that human beings can look at 18 kilometers of open, storm-lashed sea and say, we will build a road beneath that. We will pour concrete that outlasts cathedrals. We will sink structures heavier than warships and connect them with the precision of a watchmaker. We will do this not because it is easy, but because the alternative, the ferry, the delay, the division, is no longer acceptable. Somewhere on the floor of the Baltic, right now, a 73,000-ton concrete element is settling into its gravel bed, aligning itself with the one beside it, gaskets compressing, water being pumped away, the joint sealed tight against the crushing pressure of the sea above. Inside that element, the lights are already installed, the ventilation ducts are already in place, the road surface is waiting for its first tire. And in the control room on the surface, an engineer watches a screen full of data points, confirming that the placement is within tolerance, that the seal is holding, that the next piece of this extraordinary puzzle is locked into place. This is how you connect a continent, not with speeches or summits, but with rebar and concrete, and the stubborn, magnificent refusal to accept that an ocean is an obstacle. The Fehmarn Belt Tunnel is being built right now, and when it is finished, Europe will never look the same again.